an absolute value is greater than that, you get answers where you have this or that, right? So if we graph that, that's like everything less than negative a or greater than a. And usually those don't overlap. There's exceptions to the rule. Like what if they did overlap? It might end up with all real numbers. Or sometimes the exception to the and inequality is that what if they don't overlap? That's an answer of like no solution. Those are exceptions, but for the most part, and meets in the middle or goes in opposite directions. And obviously you could replace those with less than or equal to, or greater than or equal to. The big thing to remember when you're solving these is you should have two equations when you're solving them, and that's what people forget. So let's look at an example here. Right, so on your test, on your homework, it's just going to say this. It's going to say solve the absolute value of x plus 3 is less than 5. So one answer that everyone always gets is when you just solve that, right? You solve x plus 3 is less than 5. You have to remember less than means and, greater than means or. Like I just have that like ingrained in my brain. Less than means and, greater than means or. So when I see this, I know that it's an and inequality, which means I can do two things, all right? Algebra 2 way, maybe we could say this. We could say x plus 3 is less than 5, and x plus 3, you definitely got to change this to a negative 5, but do you remember what else you have to do? You got to flip that around and make it greater than. Maybe advanced math way, I'm going to just write this up here. You could say less than 5, greater than negative 5, and you could make it all squished as 1. No, maybe. As long as you have that word and in there and you put it together at the end correctly, or you write out the solution correctly, you don't have to write it all at once, but just know the book's going to write it all at once. It's kind of the nice way of writing an and inequality is that you can write it all at once. So you could just solve both of these separately, or the really cool thing about an and inequality is you can solve it all at once. And you could say, I'm going to subtract 3 here, and over here. And I get my answer all at once. So I would get negative 8 is less than x, which is less than 2. And I like writing it like that because it reminds me that it's everything in between negative 8 and 2. You need to write these in the right notation, which means you have two options. One option is you can write it in that set notation, and a lot of people like set notation. We've talked about it before. The Algebra 2 book uses set notation. People like set notation because all you got to do to write something in set notation is you put those little brackets around it, and you draw the line, and you say the solution set is all values of x such that x is between negative 8 and 2. I like interval notation, and I want to encourage you to at least try it on some of these, is to write your answer in interval notation. Interval notation is using the brackets and the parentheses. So if I want to say everything between negative 8 and 2, not including it, what would I say? Would I have brackets or would I have parentheses? Parenthesis, negative 8. And if you see a multiple choice question, the answers are going to be in interval notation in this book. All right? On a test, if I gave you a problem to solve this, if you wrote it in set notation, I'll give you credit for it. But just know multiple choice questions are always going to have interval notation. I'm going to use interval notation a lot as well. But you need to make sure you do the right notation. One of those. I love this. Again, I kind of have drilled in my head, less than and greater than or. So I know right away that it's an or statement. And when it's an or statement, they don't overlap. So when it's an or statement, you really do just have to solve two separate problems. Same rules as up here. Greater than or equal to 5. Or right? So we flip our inequality sign and we make it negative. And we can't put this one all as one thing because that's what makes it an OR. Again, just another reminder about solutions here. It's okay to give a fraction answer. I actually prefer a fraction answer, especially when it's a repeating decimal. So x is greater than or equal to 7/3. Or add 2 and get 3x is less than or equal to -3. Remember, just silly little things that are easy to forget in math. Remember, if you multiply or divide both sides by a negative, you got to flip that sign again. Sometimes I can trip you up. This one we did not divide by negative, so I don't have to flip it. But I just wanted to mention that. And again, the right notation. Set notation, we can just put those together and put the little brackets around it. That's why people like set notation, I think, because you kind of don't have to think about it. Interval notation, we're going to need two separate intervals because it's this or that. So the interval for, all right, let's do the last one first. The interval for everything less than or equal to -1, you can tell me what that looks like. Everything less than or equal to -1. Everything less than or equal to -1. Or, and we talked about this on one of the very first days in here when I gave those problems to do, about that symbol, right? Do you remember what symbol we use when we write two intervals together? I call it a U because it stands for union. It means or. And then for greater than or equal to 7/3, we're going to start at 7/3 and where we're going to end? Infinity. So, what? Nothing. And if you were the other way, that's okay too. If you started with this one and then that one. And again, if you wrote it like this, such that x is less than or equal to -1, or x is greater than or equal to 7/3. That's also another notation. I'm just really trying to push the interval notation on you. Questions about that? That's the absolute value stuff. They throw it in here with this because you have to do it's an and or. But the other thing, the reason that they really throw this in is because of the quadratics. Because we just talked about solving quadratics in 6. We could also try to memorize rules for this one too, of like when is it and, when is it or, just like with the absolute value. But what if it wasn't a quadratic? What if it was something to the third power or the fourth power? Those rules go out the window. So I'm going to not focus on the rules of what's and what's or. I want to focus on how we can do it if we didn't know that shortcut on this. Step 1 on this is you want to just solve it like it's a normal equation, which means what are the 3 ways that we could solve this equation? Factoring, quadratic formula, complete the square. It doesn't matter which one you choose. For me, if it's factorable, especially if it's small numbers like that, I'm going to try factoring first because I have extra stuff to do as well. So if you like steps, and I'm like steps. So step 1 is you're going to solve the related equation, which means kind of forget about the inequality sign for a minute, and let's just find the solutions. And if I was going to solve this equation, I can already see that it's factorable. It's x and x. What multiplies give me 2, that adds give me 3. Oh, it's amazing. It's just 2 and 1, right? And I'm going to change that to an equal sign for a minute just because I'm just solving the equation. And I would get answers of x equals -2, x equals -1. What does that represent on the graph? If I solve a quadratic like that, what do those numbers represent? Do you remember? the zeros, right? So if, and you don't have to graph this every time, but just to show you here, if I graph this at -1, at -2, that means that's where my graph would cross the x-axis, right? And maybe remembering a little bit more, could you tell me which way this is going to open? Up, because x squared's positive. If it's negative, it opens down. Remember that? Which means it's going to look something like that. I don't really know exactly where the vertex is, but I'm just winging it. When we're solving an equation, all we care about is exactly where it touches. So that's why our answers are -2 and -1, and we move on. But when it's an inequality, we're going to be shading if we graph this, right? We're either going to be shading inside the graph, and if we shade inside, we would be shading in between those numbers. It's an and. If we shaded outside that graph, it would be an or statement, right? And we could actually just graph it every time and check a number and see what works, and that works too. But sometimes they're going to be kind of awful numbers, and you're not going to want to graph it, which means you could check this algebraically. So I'm going to say, what would be my possible answers? Well, what if I shaded over here? Do you agree that that would be the solution, like -∞ to -2? Do you think that would be the solution if I shaded here? What would be the solution if it was shaded inside? -2 to -1. And what would be the solution if I shaded over here? -1 to infinity. How did I know to put parentheses there and not brackets? Goes all the way back to this sign up here, right? This is what determines whether I do this or not. With me so far? And maybe you don't have to write this out every time. You can just actually check them. But those would be my possible solutions. I have to figure out which ones work. One option is graphing, and that's what we're going to look at tomorrow, is actually using the graphing calculator to do this. But doing it algebraically, could I just pick a number between -∞ and -2 and plug it into this problem and see if it makes it a true statement? Do you remember doing that before? Like checking numbers if they work, maybe? I don't know. You have to do this with all numbers. With a line graph? So like you just drew the line and checked?
Yeah, basically.
So like instead of writing it like that, maybe you just did -2, -1, and you just picked numbers in between there?
Yeah.
That works too.
Draw it, not a picture.
Yeah, so either way works if you want to draw the number line or you want to do this. But what you got to do is you have to check numbers. So if we checked a number less than -2, any number in there, do you agree that -3 would be less than -2? And I'm just going to see if it works. You can plug it in right here. You can plug it in right here. Doesn't really matter. If I plugged in -3, if I plugged it up here, I would get 9. 3 times -3 is -9 plus 2. Or I'm going to write that up there. 9 minus 9 plus 2. Is that true? Is that less than 0? Not true. So I just write no. He wrote a frowny face. If I plug in a number between -1 and -2, oh. What do you have to pick if you pick a number between -1 and -2? A fraction or decimal. Or could we skip it for now and go to this side? Because pick a number on the other side of -1. My favorite number every time I'm going to pick it is 0. Whatever interval 0's in. And if I plug 0 into that function, I'm also going to get 2, right? 0 plus 0 plus 2, which means that doesn't work. Or maybe you're already thinking that you already knew it didn't work. Because if it's a quadratic, if the one side over there is outside doesn't work, does it make sense that the other side's not going to work and that has to be an in-between one? Which means the nice thing about being a parabola, if you know it's a parabola, is you don't have to check all of them. Means the middle one should work. Let me show it for sure. If I check -1.5, here's where I like to check it. I like to check it where I factored it because I just worry about positives and negatives if it's less than 0. If I take -1.5 plus 2 times -1.5 plus 1, I don't really care what it is as long as it's negative. So negative 1 1/2 plus 2, do you agree that that's going to give me a positive number? Negative 1 1/2 plus 1 is going to give me a negative, and a positive times a negative is a negative, which is always less than 0, which is how I know that that's the answer. And again, you don't have to check all of them because it's a quadratic. It's either going to be in between or on each side. So you could just check the in between one, or you could check the side ones to see if it works. But I do want you to write your answer. That's why I kind of like to write it like this, because then I can just go back and say, oh, this one worked. So I already have it written out the right way. Those didn't work. Or if you just do the number line, then underneath there you need to write the solution set, that is an and inequality. Questions about that? We can have a rule. I remember when I taught Algebra 2, if you set it up a certain way, then you can do the less than means and, greater than means or. But you always have to make sure that the that the functions on this side and the numbers on this side, and if the x is negative, then the rule it flips, and it just seems to me like a lot of crazy rules that you have to memorize, whereas you could just actually check it. So that's why I'm showing you this, because I think memorizing the rules is sometimes a little bit crazy on this. And it only works for quadratics. It doesn't work for third degree or fourth degree, which we're going to get into very quickly. All right, do I have another one on here? Another one. Again, you just need to get in the habit of getting that equal to 0, so I'm just going to automatically subtract 20 over. We could try to factor this where we would take 2 times 20, or negative 20, and get negative 40. But if you just want to do the quadratic formula, like that's going to work as well. Because sometimes factoring is not going to work, and so you might waste some time doing that. So, you want to just do the quadratic formula? Does it work?
Yeah.
Because 2 times 20 is 40. You could pick 8 and 5. Yeah, I think it does. I like factoring. All right. Right, because you would get negative 40. So we could say negative 8x, no, positive 8x minus 5x. Okay, because 8 minus 5 would be positive 3. And again, I just change this to an equal sign, because sometimes if you forget and you don't change it to an equal sign, you're going to just bring that sign down and forget that you actually have to check. As long as you remember to check, it's okay if you bring it down. I should have 6th hour on the little trick of dividing. I was better at it. So I factor out the 2x, and then I'm going to get x plus 4. And remember, you want those to match, right? So you have to take out a negative 5. And again, if you're not a big fan of factoring, it's okay. You should probably could do the quadratic formula about just as fast, especially if you have a calculator. The big thing with the quadratic formula is just watch your signs and make sure you simplify it all the way, because you are going to get nice answers on this. I think you should get negative 4 and positive 5/2. If you got imaginary answers when you did the quadratic formula, that means that graph never touches the x-axis, so the answer is no solution. There's no solution to that because it doesn't shade. If you got an irrational number, like you can still set up an and or an or, it's just a lot uglier, and maybe we'll look at one of those eventually on how to do that. So if we just set up the number line, negative 4 and 5/2, right? Again, remember it's a quadratic, which means I think we could just check one place, and if it shades in the middle, then you know that's the answer because it's a quadratic. And if it's on either side works, then you know that it's shaded on the outside, and you don't have to actually check all 3. Right? Does that make sense? We don't have to check all 3? Guess which one I'm going to pick, the middle, the outsides, or the middle to check? The middle, because it has my favorite number to check in there, 0. And does that work when I plug 0 in there? If you go all the way back to the beginning, or you can use any of these simplified ones, but if I go back to the beginning, I'm going to get 0 plus 0 is less than or equal to 20. That is true, which means that that should work.
So can you just like look at
The sign, less than and greater than or.
so but like if it was like an or, then you just check the outside.
And the trick is, if this was a negative x squared, it's now an or. And so I just think that
So negative.
I like to remind you that it's great to use less than and greater than or, but if it's negative, it switches, and so if you don't know that rule, it's nice to at least verify it really quickly. But yes, if you notice that, if you notice the last one was less than, and it was and this one's less than, it's and, it's true, as long as the x's are over here and the numbers are over here, and as long as x squared is positive. But yes, that is true. So this one's equal to, right? So this would be bracket negative 4 to 5 halves. Okay. The one other thing I want to talk about today is projectile motion, and we're going to talk about this a lot. It kind of looks a little scary, but it's basically you get a parabola when this happens, and so it shows up a lot. Your book tries to say really fancy stuff here, right? But it says, suppose an object is launched vertically from a point s sub 0 feet above the ground with an initial velocity of v sub 0 feet per second. The vertical position s in feet of the object t seconds after it is launched is... Okay. You really just need to know where the numbers represent, which is all up here in this paragraph, but if you want to write it out where it's a little easier, t is time in seconds, unless it tells you differently. S sub 0 is your initial height. Put HT for height. V sub 0 is your initial velocity. And then S is your ending height, right? Like S is the vertical position in feet. So I'm just going to put position. Usually in feet. The negative 16 comes from acceleration due to gravity times something. I don't know. I'm sure Miss Dodd can explain that a lot better than me. That means this is projectile motion for Earth. If we were measuring projectile motion on the moon, it would be a different formula. It wouldn't have that negative 16 there because acceleration due to gravity is different on the moon. All right, but we're assuming we're on Earth. And this means if I took this pin and I launched it from my height, right? My height would be the initial height, S sub 0, and I threw it up. It's going to make a parabola every time. I used to throw my pins all the time, but not my new fancy smartboard. I'm scared to break things. Also this thing. So if I threw this up, it's going to every time go up and reach a maximum point and come back down. It's going to make a parabola. And so that's what this formula is letting you solve for missing parts. All right. So it's going to show up a lot. If you take calculus, we'll use this all the time as well, the position function. So aren't you so glad I printed these out and you don't have to write this down? It says a projectile is launched straight up from the ground level with an initial velocity of 288 feet per second. When will the projectile's height above ground be 1,152 feet? On a test, I'll give you that initial formula. S equals negative 16 t squared plus b sub 0 t plus s sub 0. You have to know what it represents, and you have to know how to plug in the values. So an initial velocity of 288 feet per second, where does that 288 go? For which letter? Initial velocity is v sub 0. S sub 0 is the initial height. What is the initial height of this? Is the initial height 1,152 feet? It's 0 because it's launched from ground level, right? So it's just plus 0 here. Where does this 1,152 go in? That's the ending height. So you got to know where to plug values in. And then this isn't super pretty here, but this is a quadratic. If it was me, I'm going to move everything over that way to make my t squared positive. 16t squared plus super great on this problem is those numbers are all divisible by 16. That makes life a lot easier, right? Always look to see if you can make things simpler, even if you're going to use the quadratic formula. But that becomes 18t. I know the bell's going to ring in like 2 minutes, but hopefully we can get through this. Don't run away. Plus 72. Oh, that makes things so much nicer because now I think we can factor that. No, it multiplies to give me 72. Then adds to give me 18. 12 and 6, I think. Is that true? And it's a minus in the middle, so that would be minus and minus. You get the same answers if you did the quadratic formula. We're going to do a lot more with this besides this eventually, but I got 2 answers. How could I launch an object and it equal the same height at both 12 seconds and 6 seconds? Don't leave. We got to answer this question. Right, that's the path it's going to take. How is it going to equal the same height at both 12 seconds and 6 seconds? Here. It goes up and back down. It's a parabola, right? So it's okay to have 2 answers. I think your homework is on this paper, though, right? Notice that 18 and 21 you don't have to do yet because you got calculated.
Mr.
Goodbye.
Carl McAllister, Kendall Thompson,